Hello once again, class, and welcome to another mock lecture. Today I'm going to teach you guys a shortcut for long division that's called synthetic division. We are not going to use this strategy for all types of polynomial division. I'm going to just teach you how to do it on specific types. But if you remember from the last video where we did this is one of the situations where we actually can use synthetic division. So let's keep this on the screen here so that we can compare the two methods, and plus then we can see what the answer already is, which was this here, 2x squared plus 3x minus 2 plus the remainder 1 over the divisor x minus 3. So traditionally, we set things up like this. With synthetic division, though, there's a different setup. Okay, here's the shortcut. We're going to start by drawing a kind of a half of a box, half a square, if you will, the right corner. And inside of that box, we are going to put what makes the divisor 0. What makes this divisor 0 is the number 3. Because if you plug 3 in for the x here, then you would get 0. So we got to put 3 in this box. That's the first thing we have to do. Next, we're going to list, after this box, we're going to list all of the coefficients for our dividend. So we're going to start with 2, and then we'll have negative 3, negative 11, and 7. And then I'm going to leave some vertical space and draw a horizontal line kind of underneath all this stuff. Okay, and here's how this works. The very first number, which in our case is the number 2, we're going to bring that below this line. Now, once you have a number that's below this line, you're going to move diagonally up and to the right position. So we're going to come up to here. We're going to move to this position here. But to get above the line, what you have to do is you need to multiply by whatever's inside the box. So I'm going to multiply the number 2 by 3. And that's going to give me 6 up here. To get below the line, we just do the addition of the two numbers that are aligned. So here we would just add negative 3 and 6 to get 3. And then that's the pattern. So we add and then move diagonally upward by multiplying by what's in the box. Add, multiply by what's in the box. Add, multiply by what's in the box, add. Okay, that's the pattern. So we're going to take 3, multiply by 3. That's going to give us 9. Negative 11 plus 9 is negative 2. Times 3 is negative 6. Oh man, did I add right? Okay, I did. I just forgot my negative. That's a negative 6 there because negative 2 times 3 is negative 6, and so we get a remainder of 1. Oh man, that negative sign is going to be missing for the whole time. Just pretend there's a negative there. There's a negative there. But that's our remainder. But then, so what are these numbers? 2, 3, and negative 2. What are these things here? Well, look, 2 is the first coefficient of our quotient. 3 is the second coefficient of our quotient. And negative 2 is the constant of our quotient, and so that's what this represents. In this case, 2x squared plus 3x minus 2 is the quotient of this division. Now, the thing that happens is when you're dividing, for us, synthetically, the power of our quotient is always going to be 1 less than the degree of the dividend. And there's a reason for that, and we're going to get into that in just a second. But again, if we're going to write our answer, then we would have, quotient plus remainder over divisor, and then we'd be done. Now, I'm only going to focus on teaching this strategy to you guys for division when 2 conditions are met. The first one is that the divisor has to be linear, and the second one is that the divisor has to also have a leading coefficient of 1, so both of the conditions are about the divisor. And if you put these 2 conditions together, there's really only 2 types of divisors that we're actually going to be allowed to use this on, or at least that I'm going to teach you how to use this on. You actually can use synthetic division for things like quadratic divisors, but I'm not going to focus on that. That's a whole nother ball game. So we're just focusing on kind of the basic synthetic division. And it's when the divisor is either this or this, right? Like it was in that example that we just did, right? X minus 3 was the divisor. So that one works. The other example that we had from last video was this one, but notice the divisors, it violates both of the properties, right? It's not linear, it's quadratic, and it's also got a leading coefficient that is not 1, it's 3 in that case. We could make the first one not comply with the conditions if we put a coefficient on there, like 3, right? So now it doesn't work, but it will here. And this is actually why the degree of the quotient is always 1 less than the degree of the dividend. We're dividing by a linear thing. So the degree is just subtracting 1 away. It's kind of adhering to the exponent property where when you have like x to the, let's just call it m, divided by x to the n. Well, that's equal to x to the m minus n, although in our case, n is actually 1, so we're subtracting 1 away from whatever the degree of the dividend is. All right, so let's do an example. All right, example number 1. X cubed minus 3x squared plus 7x minus 4. We're dividing it by x minus 5, which is linear and has a coefficient, a leading coefficient that is 1. So we're going to use synthetic division on this. I should also mention that you don't have to use synthetic division. If you like long division, you can always do that. And it will be a method that you can use regardless of whatever the dividend is. This is just one viable shortcut for you guys. Okay, well first we need to figure out what makes the divisor 0. What makes the divisor 0 is 5. So I put 5 in the box, and then I go ahead and I put all the coefficients on there. 1, -3, +7, -4. Leave some vertical space, and then draw my horizontal line. You always bring whatever your leading coefficient is, gets dropped below the line right away. And then we multiply that by what's in the box, which in this case is 5. So we get 5, and adding 5 and -3 together, we're going to get 2. Multiplying that by 5 gives us 10. Adding to 7 gives us 17. Multiplying by 5 gives us 85. And then subtracting away 4 or adding -4 gives us a remainder of 81. So these represent the coefficients for my quotient. So we've got 1x squared plus 2x plus 17, and then plus the remainder, which is 81, over the divisor, which is x minus 5. So we're still writing things as quotient plus remainder over divisor. That part hasn't changed. All we're doing is just changing the way that we're doing the division, but our answer and how we write it is going to stay the same. Example number 2, x cubed plus 8 divided by x plus 2. Now, if you watched last video, this should throw up some red flags for you here a little bit. If you don't remember, here's a small excerpt. If you look at the powers of x, they go from 4 to 3, but then the x squared term is missing before it goes to 1. Now, one thing that I think is going to be important to get into the habit of doing is making sure that all of the terms are actually present. Later on, not putting in this 0 placeholder, which is what I would do to fix it, becomes a much bigger issue. So it's good to get into the habit of doing it now so that when we learn another method in another video for division, we don't get tripped up by this. So the incorrect way to do this would be to just straight up use 1 and 8 in the synthetic division. Right? This is what you would get, but then how do you even interpret this? Is this, because we know the degree is supposed to be 1 less. Is it x squared plus 6? But then where's the coefficient for the x term, right? So this isn't it, right? Just like in last video, what we have to do, this is not an option at this point. For synthetic division, you have to put in the zeros. For long division, right, it was just a suggestion, but here we have to do it. So we should write the synthetic division like this, okay? Again, I kind of glossed over this, but -2 is what makes your divisor 0, right? It's what makes this thing 0 if you plug -2 in for that x. So -2 goes in the box, and then we just do synthetic division. So we drop down the 1, multiply by what's in the box, which is -2. Adding -2 to 0 keeps it at -2. Multiplying by -2 turns it positive. So now we're at +4. Adding with 0 is still 4, and then you multiply by -2 to get -8, which actually means we get a remainder of 0. So our answer is quotient plus 0 over divisor, or just 0. So it's just really the quotient, x squared minus 2x plus 4. And remember that whenever you get a 0 as a remainder, what that means is you've technically discovered a factor of the dividend, right? It turns out that x plus 2 is actually a factor of this thing. That's why it's dividing into the polynomial evenly. So we can technically kind of factor x cubed plus 8 into x plus 2, quantity x plus 2 times the quantity x squared minus 2x plus 4, which, if you knew the sum of squares factoring formula, then I guess you would have known that already. But, but here you go. Now we don't have to, right? We just see that x plus 2 is a factor because we got 0 as a remainder. Okay, again, we're heading in this direction. This is going to be useful information in a future video. For example 3, I want you guys to try this one. Be careful because there's a placeholder you're going to have to be aware of before you write this thing out in synthetic division form. But go ahead and pause the video here and give it a shot. All right, here's what I got. I dropped down the 3, multiplied by 3 to get 9, added to get -2, multiplied by 3 to get -6, added to get -6, multiplied by 3 to get -18, which gave me -8, and then multiplying by 3 is -24. So I ended up with a remainder of -23, and so my answer was 3x cubed minus 2x squared minus 6x minus 8, and then minus the remainder 23 over x plus 3. If you had written it like instead of this, if you had put plus -23 over x minus 3, that's the same. Since this is just a single term though, I decided to write my negative in front of it. Okay, but that's it. Just a quick shortcut. You can only use it on linear divisors with a leading coefficient of 1, or at least that's the way that I went over in this video. If you're interested in how to do it for quadratics, you feel free to search YouTube for videos that other people have done, and I may do it sometime in the future. But anyway, hopefully you guys learned something. If you have any questions, leave a comment below or shoot me an email. Thanks a ton for watching, and I'll see you in the next one.